everyone, my name's Tim Kington and this is Coding is for the Birds. Daisy and I are building a JVM and it's time to do some refactoring. If we continue down the path that we're on, we're going to wind up with way too many opcodes. So we need to find a way to combine some, and we can also fill in some of the gaps. So far we've been sort of writing a little bit of Java code and filling in whatever opcodes we wind up needing to get that to run, but we need to start taking a more systematic approach. Let's step back and take a look at what we're going to have to do if we continue down the same path. Here we see a list of all of the opcodes and mnemonics. Now there are several pages here. But if we continue down the path we're on, we're going to have to create a class for nearly every one of these. We're going to wind up with an awful lot of classes. I think we probably want to find a way to combine some of these. In some cases, that's going to be easier than others. So this group here is loading values from the constant table. This group is loading constants. So these can all be combined into one opcode, I think. These are all going to be pushing something on the stack, or maybe two opcodes, but the I loads will load an integer. F loads load another 32-bit value that we're going to treat as a float, but it's still the same size. The long and double loads will be loading two 32-bit values, right? These are 64-bit values that will take two slots on the stack. So we could combine those all into a single operation. And we can do the same with these loads that take a parameter. It's unclear whether we can combine our stores. I think we can. We probably could combine the F stores with the I stores because they're dealing with 32-bit values, and we could combine the L stores and D stores. So I think we're going to be able to collapse a large number of these opcodes into just a handful. These are array loads and stores. We're not going to worry about those for the moment. We have some special stack operations. These will probably just create opcodes for each one. Our math operations can probably be combined quite a bit. So we have a bunch that are going to deal with 32-bit values like I add or F add, I sub and F sub, and so on. And many of these are going to pop two values. Well, pretty much all of them, I think, are going to pop two values, apply some operation, and push the result. So we can probably combine all of those into a single opcode class. And it can pop two values and then have a switch statement that just decides what operation to apply and then pushes the result. And then we've got our conversion opcodes. We can probably combine all of these into one as well and just have a switch statement over the type of conversion that we're doing. So let's try to do that and get the rest of these basic opcodes implemented. Also, I guess opcode really shouldn't be called opcode. It should probably be called operation. Opcodes are really the numbers that represent the operations. So maybe you call this operation. And we'll rename these as we go, I suppose. Let's start with our loads. So right now we have an I load and a D load. These are loading local variables onto the stack. So we could have an operation here that just takes the index where we're going to start loading the locals and adds them to the stack, or we could stick with two loads, one for a value that takes two slots like this, and one that takes a single slot like our I load does. I think that's probably fine. We can probably just keep both of these, and that will take care of all of these instructions. So let's go ahead and make sure we've got all of these taken care of. Let's rename this to just load operation, or maybe just op. And we'll rename our dload to a load 2. Maybe. I don't know. They say naming is hard. I find it's true. All right. And then we'll drop this listing here. And we can go through and make sure we've taken care of all of them. All right. So our dloads from 38 to 41 are not in here. That's interesting. I thought we had already done those. Oh, I'm looking at the wrong. Yeah. Okay. I need to look at the hex value. 26 to 29. All right. These iloads here, or the ones here at the beginning, are loading a constant that is beyond the indices we can handle here. So constant number 4 or higher. So let's take a look at one of those. 15 hex. So index is a byte. We can treat these all the same way, I think. Let's check. I guess the dload is going to be handled separately anyway. All right, so iload is 15, fload is 17. So 15 and 17 we can definitely handle that way. So we'll say 15 and 17. I guess I can put a comment for each. This is an iload. This is an fload. Maybe we should do it this way just to make it obvious that we're combining them. Okay, so then we need to get the index. So our byte index is going to be the next thing. We can't use index. It's going to be byte const index, maybe. That's already used. Yeah, switch statements and scoping are very annoying. Let's just go ahead and put these out here. So we got the const index, and then we'll add a new load, const, and we're going to use const index. Okay. That should work for those. Okay, so we got iload and fload done. I think we're going to ignore the A for now. That's handling references. So until we've thought about references some, I don't think we should attack that. Iload 1A to 1D, I think we already had done. Yeah, 1A to 1D, okay. We can do fload the same way for 22 to 25. So let's do that. It's going to be 22 to 25. We subtract 22. Okay, so that should take care of these four. And now we need to handle some of these double-sized ones. We've done the double load, which was 26 to 29, and the L load is going to be the same as that. So this is 1E to 21. Long load. And so we're going to go load two things. And we're ignoring the address operations. And then we need to handle these single ones, the L load and D load, so 16 and 18. We We get an index, which is a byte. And I'm sure the long load's going to be the same. Okay. So it's 16 and 18. We want to do it much like this. We get our constant index the same way, but we need a load to opcode. Is that not what we called it? Load to op. Okay, and we should rename load const opcode. This should be. Wait, is that not the one we're messing with? Wait a second. This is not a load const opcode. This is a load op. Load to load, load to load. Okay, so I think we took care of everything except for the address operations there. All right, next I guess we'll look at the const operations. Now 2 through 8, we've already handled here with our iconst. So we can get rid of those. And we're doing a by push here, which I guess is fine, but when we push the value here, we don't really treat it as a byte, right? We convert it to an int and we push it. So we don't really need separate opcodes for these. So let's rename by push to just be push op. And it can hold an int value. We can convert it when we create the op rather than inside the op. And execute will push it. And then we can get rid of our sci push that we created. We don't need this operation. All right. So here we're pushing a value. See, we were converting it to a byte to put it in the push op, and then we were converting it back to an int to put it on the stack. So that was pointless. All right, so then fconst. We want to, so this one we really do need a different op. We need to convert the float. No, we don't. We can still use the same op. But what we need to do is convert our float into the 32-bit int that we're going to put on the stack. So this can still use the same operation. All right, so 0b to 0d. So let's add a case for that. So 0b, 0d, this is an fconst. The value is going to be a float, and it's going to be opcode minus 0b. And then here we're going to push the raw value of the float. So we need to say float.float to raw int bits. Well, much like we did with our doubles. So opcode minus b will give us 0, 1, or 2. We convert that to raw int bits and put it on the stack. All right, so that should be fine. We also have an error down here because of this si push. So this is going to be a push op instead. All right, so that takes care of our fconst. Let's take care of the lconst and dconst. So 9 and a. So we'll do something like this. This is an lconst, and our long value will be opcode minus 9 And then we're going to do a push op. This is going to be a push to op. And I guess for a push to op, we'll give it a long to push. So this is fine. And then for our double, that's going to be E and F. So it goes here. And this will be our deconst. And then double value is going to be opcode minus E. And then we're going to do a push to op, but this time we have to convert the double first. So it's double dot double to raw long bits of val. All right, so we're going to need a push to op. And it's going to have a long, and we need a constructor. And then in execute, we're going to push the high and low parts of this. I think this is happening enough that we should add a function to operation for it. Oops. Let's do that. So it can return an array of int, and we'll call it split long, I guess. And this will return a new int array. I really wish we could return multiple values in Java, but we can't. So we'll return the high and then the low. So this will be the high is going to be int of val right shifted 32. And then the low is val right shifted 32. And we have to cast that to an, I'm sorry, it's just val, cast to an int. And we've been doing this in a few places, so maybe we should replace those as we go too. So here we can say int array parts split long val, and then we'll push the high and then the low. So stack dot push parts. Or actually, what we really want here is a push long, don't we? So we'll say push long stack, and we'll add that in here too. And really, the push double is already doing that, isn't it? Yeah, so we want push long, and then it's going to do, we'll split it. I don't know if we'll end up using that anywhere else. This needs a stack. And then we'll push the two parts. So we're pushing part sub 0, which is the high part. And then we push the low part. And this needs to be void. And then push double is really already doing that, right? So what we really want to do here is do a push long of the converted double. So maybe this function isn't worth having since it's one line. I guess we'll get rid of this function. Okay, so back to here. We do a push long, we need to pass the stack and the value. And then translator's unhappy because it hasn't imported that class yet. And we might need to fix up some of these opcodes. We're going to go through them anyway and combine things, so I'm not going to worry about that quite yet. So we got the const opcodes in there. And we did the D const, right? Okay, so those are there. loads in our const. Now our stores are storing into the local variable table. And again, they don't really care much about types. So I think we can combine all of these as well. We're skipping the A's for the moment. All right. I store 0 through 3 definitely exist already, right? The 3B, yeah. So we have this already written. Now our iStore opcode is really popping something and storing it in the local vars array. So I think we want to make this more general. So we're going to call this store op. And we're going to use it for all of our 32-bit stores. So our iStore 0 to 3 were there. iStore 36 hex, I don't know if we've done that one. We have not. Okay, so let's do these constant ones first. We'll get the fstore. So fstore is 43 to 46. And it looks just like this. Stores. And our var index will be opcode minus 43. And that's it. So this op really doesn't care what the value is, just that it's 32 bits, because we're going to take it out of a 32-bit slot on the stack and put it in a 32-bit slot in the local vars array. And then our iStore and fstore, so let's look for 36 in here. So this gets an index, which is just a byte. All right. And it was 36 and 38. These are iStore and fstore. And this is going to be local index, which I guess already exists or doesn't exist. We're going to want to use that again, so let's put it up here. Whether it exists or not. Where was I? Right here? Okay, local index. And then we're going to add a store op with local index. Okay, so that should take care of those two. And now we need our lstore and dstore. And we had done at least one of these. Yeah, so dstore is there. This operation is popping two things and putting them into the local variable array. So that's fine. This is going to be called store2op. And we can use it for our longs too. So our longs are from 3f to 4.2. And our index is opcode minus 3f. And we're going to do a store2op with that. Okay, so now dstore and lstores are done. We're ignoring astore. Let's look for 37 or 39. Are we handling those? I don't think we are. Oh, we are. 39 is already here. So we'll just add 37 to this case. This is dstore and lstore. And we're going to call this, this will be local index. All right. That takes care of our store operations. All right, let's get the rest of this back to where it'll compile. All right, we got rid of push double. So this is going to be push long, and it's going to be double to raw long bits of value. Okay, and this, we're probably going to want to combine the conversion opcodes soon too, but we won't do that yet. Add has the same problem. And this is push long now. So I think we should be back to where our test is going to pass. I guess I want to run them all, don't I? Okay, so we haven't broken anything. Now we need some tests for our new opcodes. So we have some old tests here, I guess. All right, here we've got iconst, we've got iStore, iLoad, iStore. Our doubles are handled. We load a constant double and store it. But some of these are new. The question is really about confidence here. What parts of the code are we trying to test? I feel okay about the opcodes themselves because they're so simple. It's really the translator we want to make sure that we got right. And so what I think we really want to do is take a look at each group of opcodes that we added in the translator and just make sure that we're using that group. So like here we've got the lconst, so we should have a test that uses an lconst, and we should have one for an fconst and a dconst, so on. So let's do that. We had one with a iconst, I guess. And it's going to look, well, a little bit like this. We'll just start from this code, I guess. We'll do it like this. So we're going to have an lconst1. And lconst1 is 0a. I should put 1 as a long on the stack. Then we're going to do an lstore. And we can do the one that's a predefined variable. So we'll do an lstore 0, which is 3f. And then we'll return. And if we run this, that should put 2 entries in our locals. We don't need any constants. Don't need to do this. And then we can use the split that we wrote. So here we'll pass null for constants. And then our answer should actually be split operation.split. No, that's annoying. I guess we don't really want that to be a default method. We want these to be static. And then here we can call the split long. The value is 1. And that's what we expect to see. Did I break our compilation over here? I guess we'll find out when we try to run it. Of course it won't work. Maybe it's something magical about the last test in the file. Now we have problems, okay. Back to here. Oh. Okay, so that passed. That took care of lconst and lstore. We also had lload and lstore that take the index of the variable out of the code. So let's do that. We can add that here. So our load. Oh, that's annoying, isn't it? So 16 is lload. Let's put the comment here. All right, so we need 16 for an lload. And then I guess our lstore is probably 37. Okay, so we want a 16 for an lload and a 37 for an lstore. And we'll load variable 0. And then we'll do an lstore into variable 1 or 2 because it takes 2 slots. We need 4 of these, and then this we'll say Pete parts or something. And here we'll say int array. And it needs parts sub 0, parts sub 1. Like this. Are there any other long related opcodes that we need to test here? So we have lload and store, and then we have lstore with a predefined value and lload with a predefined value. So I guess maybe we haven't hit our lload with the predefined value. Let's go ahead and do that. Even if we have in another test case, I'd like to have everything in one test case where I can see it. So if we do an lload, 1e is going to be lload 0. So what we want is an lload 2. So that's it's 2 0. This is an lload 2. And we can do an lstore 4. And now we need 6 locals, and we're going to have 2 more copies of the parts here. So let's make sure that still passes. All right, now let's do this for doubles. So lconst 1, we want dconst 1, which is going to be which is going to be 0f. And then we need a D store 0, which is 47. And then we need a D load that takes an argument, which is 18. And D store that takes an argument was also 2 higher than the long version. And then we need a D load 2. So D load 26 is 0. So 28 should be 2. And then we need a D store here. And then our parts are going to be a split long of the double 1 converted to raw long bits. So let's see if that works. All right. So we got long and double. Let's do a version of this for an int. These are all going to be i's. 1 I store 0, that's fine. We'll do an I load and an I store, but this really needs to be a 1, not a 2. This is an I load 1, I store, and this will be a 2. And then this is just going to be 3 1s. We don't need any more splitting. This is going to be 3. All right, so I const 1 is, so 2 is minus 1 here. And then 3, 0, and 4 is 1. And then I store 0 is 3b. And then an I load with a parameter, I think is going to be 15, but let's check. Yeah, I load is 15. Here, I store is going to be probably 36. Yep. So this is a 36 and a 1. And then we're going to do an I load 1. Which is 1b. And then an I store is 36. We're storing in slot 2, and then we return. Okay. All right. And then we can copy this for our floats. Okay, so f const 1 is going to be 0c, and then f store is 0 is 43, and then we need an f load with an argument, which is 17. Right, these are both 2 higher than the int versions. So load store, this is a store of 38, And then float1 is going to be a 23. And now these won't be quite right. Our value is going to be float.float2 raw int bits of a float that is equal to 1. All right. Okay, so we're testing float, int, double, and long. Are there any others that we missed? Don't think so. Long float double, long float. All right, looks like we are covered here. Well, that was a lot of changes. We managed to fill in a lot more opcodes, and we consolidated a bunch of the operation classes. So I think this was good progress. Attacking a problem like this the way I did works well in a language like Java. So as I was working through the opcodes, I also made some breaking changes to other things, getting rid of push double, or changing the methods from default to static in our operation class. I can make those changes with confidence because Java is a statically typed language, and it's going to help us track down all the places that we broke things. If you were doing this in a language like JavaScript, it would be a lot harder. Once you make those changes, you might not find all the places that you broke, and you would only know when you ran into that code at runtime. Thanks for watching. Don't forget to like and subscribe.